Okay, here's our notes for pre-calculus, section 5.4 out of Larson-Hostetler and 10.4 out of Stitt-Ziegler. Some angle formulas, and so we're going to build on that. Before we do that, I want you to warm up with these 6 problems. You should be able to do these, so try those, and then we'll come back to you and help you out with. So if I take the sine of 5 pi over 6, you get negative square root of 2 over 2. I hope you got that. Cosine of 5 pi over 6, negative square root of 3 over 2. Tangent of 5 pi over 3, negative square root of 3. What I like to say is that, well, a lot of times either your answer is square root of 3 or your answer is square root of 3 over 3. Since I've already used up a plane 3, I can't use it again, so I got to use this square root of 3. Which quadrant is it in? Fourth quadrant, so it's going to be negative. If I move on to these are building your triangle. Remember, you use the insider information to build the triangle, outsider information to read the triangle. So with the cosine, arc cosine of x, that would be x over 1. So I build that adjacent over hypotenuse and find the missing side here. So I just take 1 squared minus x squared square root. That's that side. And then take the outsider information to read. Well, the sine is opposite over hypotenuse, so I go opposite and I go hypotenuse. There's my opposite over hypotenuse. There's my answer. Now, if I have one of these, oh, this is a quadrantal angle. We haven't really dealt with this, but on the unit circle, well, I'm sorry, if you build the triangle, you get square root of 0. That doesn't make any sense, but the sine is 1 at pi over 2. So this is a quadrantal angle, and so you don't even need a triangle. You can just read that this point is 0, 1. So then the cotangent on the unit circle is just going to be x over y. So it's going to be 0 over 1. So it just turns out to be 0. Then number 6, if I build this with the insider information, this would be opposite over adjacent. So 3 over x. Find the hypotenuse, which would be x squared plus 9, square root that. And then I read off the outside information. The outsider information, cosecant, would be the reciprocal of the sine. Sine is opposite over hypotenuse, so we get hypotenuse over opposite. So I get square root of x squared plus 9 all over 3. I hope you're able to try those and do those. Now, what we're going to have are some angle identities. Hopefully you were able to do these in class last time. I hope that I remember to do these in class last time. If not, we can do them when you get to class next time, but remind me. And what we have is sine of alpha plus beta. And what we can split that up into is sine alpha times cosine beta plus or minus sine of beta cosine alpha. Notice that the plus or minus is here, plus or minus is here. Pluses and minuses stay the same, but then on my functions, sine and cosine are different. So one thing stays the same, the functions change. So now I look at the cosine some angle identity. Cosine of alpha plus beta. Now look at the plus or minus. If I have a problem that has a plus in it, over here I'm going to put a minus. If I have a problem that has a minus in it, I'm going to over here and have a plus. Now look at the two functions, cosine, cosine. So with the cosine, these two functions stay the same, but then the plus or minus changes. So I look at it with these two formulas, always one thing changes and one thing stays the same. I don't know if that makes sense to you or not, but try that. And so this is the formula for the cosine some angle identity. Tangent some angle identity is this one. I don't have any good tricks for this one, but you just have to kind of remember that one. All right. Find exact angles. So what we're going to do then, or what we can do now, is find the exact values of the angle that are sum or difference of angles that we know. So right now, what's going to happen is that you're going to be given angle measurements that aren't those nicey nice angle measurements that we've known before. So we know all the pi over 6s, we know all the pi over 3s, we know the pi over 4s, and we know the pi over 2s. We know all those. But now we're going to get something that's like this, 5 pi over 12. And we're going to have to try to rewrite it using these things in a sum or difference. That will be our practice. So let's take 5 pi over 12, for instance. Can I write this in terms of these type of angles? Now, they could have a coefficient here, too, because we've done those. We know those from the unit circle. So if I take 5 pi over 12, what's one way to do that? Well, if I look at 5, I know that 5 is, for instance, 3 pi over 12 plus 2 pi over 12. Now, when I reduce these, are these two of the nicey nice angles that we've had before? Well, this is pi over 4. And then this is pi over 6. Sure enough, that's something that I've had from up here before. So I could use these two to rewrite and use the sum angle identities in order to find the sine and cosine of something that's divided by 12. Oh, interesting. Okay. Is there another way to write this? Well, how about 6 pi over 12? And what do I have to do to get 5? I got to subtract and get pi over 12. This is pi over 2. That's one of my nicey nice. Minus pi over 12. That's one of my... Oh, that isn't one of my nicey nice. So I can't take these two and put them together quite like that. That does not help me at all. So let's see if we can try and find another one. 7 pi won't work. 8 pi over 12. So what if I go 8 pi over 12 and I subtract off 3 pi over 12? And so this does get me my 5 pi over 12. If I reduce this, 4 goes into both of those. So I got 2 pi over 3. And then here I have pi over 4. Certainly that would work. I know my 2 pi's over 3 and I know my pi over 4's. So this one would work as well. So the idea is to use two angles that either add or subtract together to give you this. Now there's other possibilities that you can use, but these are just two examples that do work. You don't want to use the pi over 12 though, because we don't know that. Okay, what can I do with pi over 12? What does pi over 12 equal? Well, there's a bunch for this one too. The one that comes to mind here for me is 4 pi over 12 minus 3 pi over 12 gives me pi over 12. If I reduce these two, this would be pi over 3 minus pi over 4. If I take those two and I plug it in here, then I can use this. Boom, I'll be able to figure out what cosine or sine of pi over 12 is. I hope you get that idea. Okay, so right now, here we go. Sine of 5 pi over 12. So right up above, we just found a couple of these. How can we rewrite 5 pi over 12? So the sine here, written in pi's over 12, so I can do this. Instead of having that pi over 12, I can do this. Sine of pi over 4 plus pi over 6 gives me that 5 pi over 12. So I've established equivalence here. Now I can take this and I can use this formula right here and write this. So I need the sine of the first angle. So this is sine of pi over 4 times the sine of pi over 6. Oh, I already made a mistake. So this is my alpha, this is my beta, so it would be sine of pi over 4, which I have there, and then it'd be cosine of pi over 6. That'd be my next term. And since I have a plus here, I match that up with a plus here. So this would be plus. And then what I do from here is I take the the sine of beta, and then the cosine of alpha. So I'm going to have cosine of pi over 4, and then the sine of pi over 6. Because that's the sine of beta, that's the cosine of alpha. So right here, what I have is I have the alpha, and then I have the beta here, and then I just plug it into this sequence. So now if I take these values, this is going to be square root of 2 over 2 times cosine of pi over 6 is square root of 3 over 2. And then I'm going to add sine of pi over 6 is 1/2, and times this cosine square root of 2 over 2. Multiply this out, square root of 6 over 4 plus square root of 2 over 4. And so I can just do it like this if I wish. So there's my answer. That would be the sine of 5 pi over 6 in exact value. Oh, that's not one of those nice ones on our unit circle, but I was still able to find it in exact terms with the square roots in there. So you could leave it like this or leave it like this. Either way works. Why don't you see if you can try this tangent one and fit that one in? Remember that you have to do the pi over 12 piece, which we had right here. That would be one option to do. Okay, so maybe try that and see. Otherwise, I'll go through it. So the tangent of pi over 3 minus pi over 4 is equal to, I'm going to be using this formula here. Now notice I used the negative because I have the minus here. So up here, I'm going to follow along with all the bottom signs. So this is negative and this is negative. So it's going to be the tangent of alpha minus the tangent of beta all over. Now what do I use down here? Do I use the plus or do I use the minus? Well, since I use the bottom here, I use the bottom here, so it's going to be a plus. And this would be the tangent of pi over 3, tangent pi over 4. Now all you do is evaluate those pieces. Now remember, tangent pi over 3, I don't need another 3 there, so I'm going to just get plain square root of 3 minus tangent pi over 4, that's going to be 1, all over 1 plus square root of 3 times 1. So what I'm left with is square root of 3 minus 1 all over 1 plus square root of 3. Now what might happen to you is that this might not be the same answer as in the back of the book. Sometimes they want you to rationalize, and how we rationalize this one again is that we use the conjugate. If you remember the conjugate, I'm going to multiply by not 1 plus this thing, but 1 minus. So what I can do is I can multiply top and bottom by 1 minus square root of 3. That conjugate will get rid of my square root. And a lot of times we don't like the square root in the denominator. So it's a squared plus b squared. So that would just be 1. I'm sorry, a squared minus b squared. I'm thinking complex. And then this would be 3. So this would be minus 3. And then in the numerator, I got to multiply all that out. FOIL. So then that would be square root of 3. Woo, I did a lot here. So I multiplied this, FOILed this out, and I get these values, and then I FOIL this out, but this gets rid of the square root for me. Then I simplify, and then I can do the rabbit method. So this 2 cancels with this 2 cancels with this 4, and I get negative square root of 3 plus 2. Now how did I check? I get nervous I'm going to make an error. So what I did is I went to my calculator in radian mode and just said tangent pi over 12, got that value. It was like 0.267, and then I did this value and I get 0.267, and I said, whew, good. I did all that little stuff correctly. So that was a nice check for me. Now what do I expect? Well, if it's a multiple choice test, you might get this answer, so you might have to get here. But a lot of times I would be okay with this. I'm not so worried about having a square root in the denominator. Now how about if I look at this one? This one I can use the inverse sine stuff. So I'm sorry, the sine function. Now when I see this arctan, that just means an angle measurement where the tangent's 1. This one means the sine where the what's the angle measurement where the sine value is x. And so when I see this, I have 2 angle measurements right there. So this is the sine of angle 1, angle 2. So I can use this thing to split this up. And so I'm going to write that. So I take this formula and I rewrite it. It does say plus, so I'm going to do a plus here. And so I have the sine of the arctan, so that's the sine of alpha, times the cosine of beta, which is right there. And then I go plus sine of beta times cosine of alpha. That says arctan of 1. Oh, these are all those little problems that we did at the warm-up. Ooh, bunch of them. Well, this one just tells me that I have a tangent value of 1. Well, that's going to be at pi over 4. So the sine of pi over 4 is going to be square root of 2 over 2. That one's pretty easy. Now, if I look at this one, arc sine of x. Uh-oh, I might have to draw a little triangle to sort that one out. So I'm going to build a triangle. So the sine would be opposite over hypotenuse, x over 1, and then this piece would be 1 minus x squared, square root of that. So if I take the cosine and read that, that's just going to be the square root of 1 minus x squared. Now if I do this bottom one, oh, I can use the same triangle. Ooh. And then I take the sine. Oh, that's just, oh, look at that. That's just x. Oh, that's right. Inverse functions kind of wipe each other out. You got to be careful of domain, though. I did not state the domain here, but x does have to be between negative pi over 2 and pi over 2 to make this work. So that's the only consideration. But I'm going to go plus, and I'm going to assume that that's true. This is going to be x. And then this one, arctan of 1, once again, is pi over 4. And then the cosine of that would be square root of 2 over 2. I don't know how much more you can simplify this, but you do have a common denominator, so you could write square root of 2. You can even shove it inside if you want. but I'm just going to go like this, and then plus, and I get something like this. Now there's lots of different forms you can write that in, but that's how I'm leaving it right now. Okay, continuing on, prove the following identities. If I want to prove the following identities, what I can do is just use these sum angle formulas or difference formulas and go ahead and plug and chug them. So if here's the cosine and here's the minus. So if I take the cosine, I look at this formula right here, cosine, cosine. So I'm going to go cosine pi over 2, cosine of x. And I ignore that minus sign right now. And then if I have this here, what I can do is I can use the symbol that's appropriate. Well, since this is minus, I'm going to use the plus. So that's going to be plus, and then this would be sine, sine. Sine pi over 2 times cosine of x. That's what we got. Some of these I can evaluate the angle measurements. The other ones I can't. Cosine of pi over 2, what's that? Well, that's 0. Sine of pi over 2, what's that? That's 1. So I'm going to be left with, in this case, oh, this should be sine, sorry. So I'm left with the sine of x. Oh, so the sine of x is equal to the sine of x. I am in business. And so there I am. And there's my smiley face. Okay? Looks like I got a black eye. Oh, I did almost there. All right, so I worked on the left side and got to the right side. Tangent. If I do this one, tangent plus of theta plus 3 pi is just still equal to the tangent. So what am I going to use here? Well, I'm going to use this formula there. So if I have tangent alpha plus beta, and I should work on one of these sides at a time. I gave myself a little bit more room, so this is going to be tangent of theta plus tangent of 3 pi all over, and I'm going to go 1 minus tangent theta tangent 3 pi. Now what is the tangent of 3 pi? Well, the tangent of 3 pi is going to be the same thing as the tangent of 0. So when I look at this, I want to say, well, this is the tangent of 0. So the tangent of 3 pi is going to be 0. So I'm just left with the tangent of theta over 1. So this is the tangent of theta. And to show this, I bring this other one down, which is right there. So tangent of theta is equal to tangent theta. No big deal. Okay, so there I am. Other problems that we can deal with show that this identity holds true. I'm sorry, this says this is solving. So this is find all solutions of this formula right here. So what I want to do is probably apply this sine identity. So that's what I'm going to do. So sine of x times the cosine of pi over 4 plus the cosine of x times the sine of pi over 4. Uh-oh, I strayed a little bit. Is this the same or not? I think it is. So then here I would have the sine of x times the sine of, cosine pi over 4. And then now I'm going to have a minus. And this is going to be cosine of x times the sine of pi over 4. Okay, so if I look at this right now, I can maybe simplify this a little bit. And let's see if we can. Oh, right here. Boom, boom. That helps me out. And then I have 2 of these. So this would be 2 sine of x times the square root of 2 over 2, because that's what the cosine of pi over 4 is equal to -1. If I solve this out, I'm going to get the sine of x is equal to -1/2. So where is that? Well, they didn't tell me an interval. So the sine of x is going to be -1/2 at 11 pi over 6 plus 2n pi, and then also 7 pi over 6 plus 2n pi. All right? So that's where we're going to have those values. So this is my solution. And I guess I didn't say solve here, but that's what I'm looking at. Ooh, interesting. Okay, how about this next one? This goes back to something when we did at the beginning of the year. But what if I have sine of x plus h minus sine of x all over h? And I want to verify that this is the same thing. I'll give you a hint. You're going to do this calculus next year. So if I simplify this numerator, I'm going to have the sine x cosine of h, and it's going to be plus the cosine of x sine of h minus the sine of x all over h. And I want to show that it's equivalent to that right there. Well, if I look at this, do I have some things in common? I'm not sure. Well, here's this term. Well, that kind of looks like that term. And then the sine of x is in common with both of those. So let's regroup this a little bit. Let's go sine of x times the cosine of h, and then minus 1 all over h. I'm using my rabbit method here. And then I'm going to write plus cosine of x sine of h all over h. Remember, I can use the rabbit method over plus signs, so I can apply the h to that, and then I have my rabbit. Ooh, doesn't look like a very good rabbit. So I'm almost home here. So this one is positive, but there it's a negative. And so I need to change that sign by flipping those around. So then this is equal to, and I ran out of room here, so I'm not writing it very well, but this is equal to cosine of x times sine of h over h. That's what I get from this piece right here. And then I'm going to be able to subtract, if I take a negative 1 out here, the sine of x, and I can switch that around. So this would be 1 minus cosine of h all over h. I hope you understand that negative there. So I didn't show this in formal fashion, but I'm wrapping it up here. But you see that I started from one side and went to the other side. All right, so that's where we're at. We used the sum angle formulas, and you proved in class this one down here. And so we'll get to that either before or after this lesson. Thanks very much, and have a good day.